This session is Fortinet Secure's Azure Cloud, broad, integrated, and automated. Brought to you by your Fortinet Azure Cloud team, 𝗦𝗲𝗀𝗀𝗀, Brent Martinez, John McDonough, and 𝗦𝗲𝗀𝗀𝗀. Enjoy.
Hello and welcome to Ignite 2023. I'm 𝗦𝗲𝗀𝗀𝗀𝗀, Principal Cloud Architect at Fortinet. I want to give a brief update on our next-gen firewall and secure SD-WAN integration with Azure Virtual WAN. It was 2 years ago at this time that we announced the strategic partnership with the Azure VWAN team to provide Fortinet secure SD-WAN, FortiGuard threat protection, and dynamic routing into Azure Virtual WAN. We have many customers taking advantage of this joint solution because it offers a significant enhancement over regular Azure networking, especially with regard to dynamic routing features. As a reminder, here are the traffic flows supported. East-west traffic, whether branch to branch or one Azure network to another. North-south traffic, branch to VNet and VNet to branch. And consolidated outbound internet edge for branches or VNets or both. Further, we extend the same connectivity across regions. East-west, north-south, and any Azure connected network, including express routes to data centers, providers, Azure VMware services, etc. We have from the beginning maintained high availability and load balancing using at least 2 active FortiGates. And we've extended the ability to reroute packets and provide symmetric inspection, regardless of which FortiGate the source or the destination packets arrive. Additionally, we have increased the capacity. By selecting higher scale units at deployment, we can now offer full threat inspection for up to the bandwidth provided by an Azure Virtual WAN hub. And of course, Azure routing intents policies are fully integrated as well. We are continuing to rapidly develop more integration and features within Azure Virtual WAN. If you have questions or would like assistance, connect with us using the alias azurevwan@fortinet.com. Also, continue to watch fortinet.com/cloudsecurity for more cloud integrations, especially within Azure Virtual WAN. Thank you and enjoy Ignite.
Hello everyone, I'm 𝗦𝗲𝗀𝗀𝗀𝗀 and I'm a cloud security architect at Fortinet. In this section, we will be talking about FortiWeb web application and API security firewall. FortiWeb web application firewall offers different use cases. One of the first use cases is the web application security, where FortiWeb has signatures for known threats, including the OWASP top 10 signatures. So it will protect you from all the OWASP top 10 attacks. It also has some machine learning based capabilities for payload detection, which is called anomaly detection. So what FortiWeb does here is it is going to build a mathematical model based on your application traffic locally, and then it will compare any anomalous behavior to the machine learning model that is built and will block based on if it is a benign anomaly or a real anomaly. It also has some great bot mitigation capabilities, like it protects you from crawlers and scrapers, which we have in our threshold-based detection. It also has collection of the known bad bots, so you're protected from already known bad bots. If say there is some sophisticated bots that goes undetected, we also have machine learning-based bot detection module that is available on FortiWeb Cloud. The machine learning-based bot detection module will protect from any of the sophisticated bots, and which is again built by the machine learning model based on your application level traffic. The main other use case is the API security protection. So with FortiWeb Cloud, it does both schema-based protection and also machine learning-based API discovery for undocumented APIs, also called as shadow APIs. And all of these features, FortiWeb Cloud and FortiWeb actually has different form factors where you can get advantage of all these features. So we've been listening about machine learning in this year, right? So why is machine learning important? And how does it work on FortiWeb Cloud? FortiWeb employs 2 layers of machine learning. So when there is some application traffic towards your application, there is this anomaly detection layer that will be built on FortiWeb based on your application traffic. This machine learning model will identify any anomalous behavior, and it wouldn't block it right away as soon as it sees an anomaly. But since FortiWeb employs 2 layers of machine learning, that anomaly will be sent to our threat detection layer, which is powered by our FortiGuard labs. FortiGuard is a threat detection team at Fortinet, and they receive about 5 million threats every week. So they compiled all these threat models and signatures based on the threats they received, and your FortiWeb is up and running with all those signatures. That anomaly now is compared with threat detection layer, and once the threat detection layer will mark it as a threat, then it will be blocked. Otherwise, if it's a benign anomaly, it wouldn't be flagged, because in order to reduce the false positives, it would be sent as a normal and benign traffic to your application servers. So why is it important, right? Usually old-fashioned WAFs add friction. Nowadays, a lot of our application life cycles use CI/CD deployments, right? Developer pushes the code. Legacy WAFs will block the request because those policies are not configured by the WAF administrator. So usually the cycle goes back to developer, they troubleshoot the problem, and that would be sent back to the administrator to tune the WAF rules. That means it adds more friction, and it takes more time for the user to enjoy the benefits of the new code. However, when you deploy machine learning, or with FortiWeb with machine learning, right? Developer pushes the code, the machine learning relearns and realigns these parameters, and user will enjoy the benefits right away, and at the same time the threats will also be blocked. Now let's look at a simple demo on how FortiWeb Cloud looks. This is where we log into FortiWeb Cloud. We click on login here, and once we log in, we'll be taken into our application view. Here is all the applications that are being protected by FortiWeb Cloud. This is my account, and if we see, this is a cloud agnostic platform. What that means is either you have subscribed to this platform or you purchased a BYO license. You can onboard applications running anywhere in any different clouds. Let's talk about one of the application which is being protected by FortiWeb Cloud. These are several other modules that we have, where we have some amount of known signatures, which include signature databases. Anomaly detection is our machine learning model. So in addition to all of this different various of this threat protection profiles or security profiles, the main focus I wanted to go on is about the API protection. With API protection, usually APIs are written in different frameworks, right? One is the Swagger or Open API, or JSON or XML or SOAP. Usually the schemas are written by the developers, so you can upload those schemas onto FortiWeb Cloud, and FortiWeb Cloud can do a schema comparison and protection. So in my case, I have an Open API validation file for my application that is running. This is a Swagger that I uploaded. So FortiWeb Cloud will be able to compare the schema for different types of the payloads, and it will block those requests if somebody is trying to send something else other than the defined types here in the schema file. However, sometimes there might be some undocumented APIs, also called shadow APIs. These APIs might be part of the code because they are later utilized, or and they're never documented. This could add an additional attack vector. So FortiWeb Cloud employs machine learning, and with machine learning we can document and discover this APIs. So when machine learning based API protection, the URLs or the endpoints that are undocumented again are built, the machine learning model is built based on the traffic that gets to those paths, and what it does is it does both schema protection and threat protection to these APIs. If you look at this API view, right, there is this Swagger that was built with machine learning by FortiWeb Cloud, and you can also see more information about the request body responses in the API description section here. We can always download this Swagger as well, but this is what it has built so far on the FortiWeb Cloud. Now let's just do a simple demo or a simple attack. I'm going to use this API users, that's the endpoint, and I'm doing some kind of cross-site scripting attack, and I'm going to send this. We see that the I get a URL, this is, and then I'm just seeing that it's being blocked by FortiWeb Cloud. It's a CSS and for the FortiWeb Cloud block page. And if you go into the attack logs here, we'll be seeing that we do see that there is some request body violation here on that certain API endpoint, and it's showing that there is some violation because there is some schema violation. And not only that, it is also categorizing that it's a cross-site scripting violation in the payload. So we see more information about that as well, and it's highlighting the payload. So that's more a review about API protection on FortiWeb. Like I mentioned before, there are several other features and use cases you can use FortiWeb Cloud for, or other FortiWeb VMs or other options, other form factors as well. If you would like to learn more or know more about this product, please feel free to contact us from Fortinet.com website or contact one of your account teams. Thank you so much for watching.
Hi, I'm 𝗦𝗲𝘀𝗀𝗶cie, Senior Cloud Architect and DevOps Engineer at Fortinet, and I just want to welcome you to Microsoft Ignite and talk a little bit about security as code with respect to Azure and Microsoft products as well as Fortinet. So if we look at the Microsoft ecosystem, there's quite a few products. There's so many things that we integrate with from Fortinet, and all of these products, or at least all of the cloud-related products from Microsoft, from Azure, have APIs. And all those APIs can be utilized to do security-related operations. Any of these items or programs or services have APIs available to them, and almost all of them are completely automatable through those APIs. And if you take a look at the Fortinet ecosystem, we have corresponding or complementary components, products, services, etc., that match those entities that Microsoft provides or complement those entities that Microsoft provides. And these, just like the Microsoft products, are 100%, in most instances, 100% automatable through their APIs. And so when you talk about security as code, there's a couple of phases that make up the security as code. There's the infrastructure as code, and then there's the policy as code. And those two items together end up making security as code. So we start with what is infrastructure as code. And Microsoft or Azure has quite a number of methods or ways that you can implement the infrastructure as code. You have the Microsoft ARM templates, the Microsoft Azure Resource Manager templates. Then there's the evolution of that with the Bicep code, which is written a little bit of a higher level, but is transpiled into ARM templates and then deployable onto Azure. There's Azure PowerShell, and the PowerShell, as well as Azure CLI. I don't have an image representing that, but Azure CLI can be used to automate Azure deployment of resources and Azure management of those resources. Of course, all of these things are really back-ending to the Azure Resource Manager API. And any API that Azure has put out is going to be capable of being called from a programming language like Python or C# or any other programming language that can make REST API calls. And then if you abstract that a layer, you have Ansible, which can be used for deployment, and Terraform that can be used for deployment. Now, typically, Terraform is going to build your infrastructure, and Ansible is going to configure your infrastructure and manage the configuration of your infrastructure. But with some of the Ansible modules that are available, you can actually deploy infrastructure as well. So that's why I've included it here. And then when you get to policy as code, this is where I want to focus on what Fortinet provides. So FortiOS is available through Terraform. There's a Terraform provider for FortiOS, for FortiManager, for FortiAnalyzer, FortiFlexVM, FortiADC, and FortiSwitch. And all of these things can be utilized to manage and maintain the policy and the configurations on your deployments within the Azure infrastructure. As well, we have Ansible modules that are the same functionality as the Terraform providers, and those can be used. But our products, just like the Microsoft products, they back end with a REST API. So any of these abstractions like Ansible or Terraform can also be those methods can also be called just through the REST API. And so when you take those two things, the infrastructure as code and the policy as code, what you end up with is security as code. You have something that's 100% deployable by automation and 100% configurable through automation, through whether it be a Terraform provider, an Ansible module, or directly calling your REST API for the Fortinet products. And combining those two, you get security as code. And where do we keep this, or where can you get access to what we utilize to do the deployment and the configuration? Well, we have repositories on GitHub under the Fortinet organization. We have Azure templates, and underneath those Azure templates, you're going to find ARM templates. There will be some bicep there, as well as some Terraform underneath those Azure templates. But then we also have a separate repository just for the Terraform deployments, how we come about with the term security as code. We take the 100% automation or 100% deployability through automation, 100% configuration through automation of the policy and the configuration, and we can then deem that as security as code. So be sure to talk to us about our security as code and how you can automate your infrastructures and your configuration of your infrastructures of Fortinet products in Azure Cloud. Thanks so much.